So now we are going to take up this first law of reflection. Okay, it is simply based on this particular figure only. Okay, it is just, I hope you can understand this figure. Okay, it is simply based on there are two laws of reflection and both are based on this particular figure only. Okay, so the first one is that the first law of reflection states that the incident ray, the reflected ray and the normal lie on the same plane. Okay, that means you can see in this particular figure that it is the same experiment. Okay, it is just the same experiment that I just told you. Okay, that you should be performing. Okay, that this is the incident ray. I hope you can see the pointer. Okay, the pointer where I am keeping. Okay, the incident ray, I am showing you the incident ray over here, right? And this one is the reflected ray. Okay, and where is the normal? Can you see the normal in this particular figure over here? Can you see the normal? Yes, we cannot see the normal, right? Why can't we see the normal? Because normal is not any real ray. Okay, normal is not a ray. Okay, normal is just an imaginary line. Okay, right? Yes. Okay, it is just an imaginary line, so we cannot see the normal anytime. Okay, right? But we can just imaginary line it is, but we can draw the normal. Okay, we can just simply draw the normal on this white paper over here, right? Okay, so the law is that the incident ray, this is the incident ray, the reflected ray and the normal lie on the same plane. Okay, this is the law. This is the fundamental first law of the reflection. Okay. Okay, so I hope you can understand the first law of reflection. Okay. Any doubts, any queries to anyone till now in any of the point that we have discussed so far? So we have to place a mirror before the light. Yes. You have to place the mirror in this manner. Okay, this is the mirror that we are placing over here, right? Okay, so somebody just asked this point, Kulkarni Nijayant 450. Okay, I hope you are able to understand this part, that how you are going to place the mirror. Okay, this is the mirror and this is the cardboard having a pin hole. Okay, this is the cardboard having pin hole and this is a torch. Okay, what is the person holding? Person is holding a cardboard having, yes, you can say that it is a comb or a cardboard. Okay, if you use a cardboard, that will be a better idea. Okay, if you use a cardboard having a small pinhole, that would actually give you better results. Okay, right? Is this thing clear to all of you? Okay, right. So I hope you can identify that this is the cardboard, this is the mirror. Okay, and okay, yeah, black strip with the hole also, right? So the second law of reflection is a very simple law. Most of you have already given me the second law of reflection in your chat boxes itself. Okay, it states that the second law of that the angle of incidence is equal to the angle of reflection. Okay, so we denote angle of incidence with the small letter I. Okay, right, and the angle of reflection is denoted with the small letter R. Okay, so the law is that this one. Law is that I is equals to R. Okay, angle of incidence is equal to R. Okay, this is the law that I've shown over here with in the green colored box over here, right? Angle of I is equals to angle of R, right? So just remember this part, right? That the angles are measured from the normal corresponding to the rays. Okay, if it is for the incident ray, if you're talking about the angle of incidence, then it will be the angle made by the incident ray and the normal at that particular point where the ray is striking. Okay, remember this very important point also. Okay, the normal can be different at different positions. Okay, it is not necessary that this particular normal will always be in this direction only. Okay, it depends at the point. Okay, it depends, it will always be perpendicular at the point where the incident ray is striking. Okay, the surface. Okay, where the incident ray is striking the surface. Okay, at that particular point surface. Okay, the perpendicular direction will denote the normal. Okay, fine. So now let us have a look at this another property of the images that is being formed by the plane mirrors. Okay, so do you guys know about the lateral inversion? Yes, so yes, absolutely correct, right? Okay, right. So you can just have a look at whenever you are standing in your in front of the mirrors. Okay, you might have observed that you are actually holding a bag in your right hand. Okay, but for your image it appears that the image is holding the bag in its left hand. Okay, right? Yes, this the conversion. Okay, yeah, this property is actually called the lateral inversion of the image. Okay, the image is getting laterally inverted. That is, it is getting sideways inverted. Okay, right side becomes the left side of the image, and the left side of the body becomes the right side of the image. Right. So this property of the sideways getting inverted of the object and the image is called the lateral inversion of the image. Right. Yeah. So yes, do you know about the the real and the virtual images? So what kind of image is formed in this particular case in the plane mirrors? Will it be a real image or a virtual image? Will it be a real image? Yes, absolutely correct, right? You all of you know this part, right? That it is going to be a virtual image, right? Why it is a virtual image? Why will a virtual image be formed in this particular case? That is the next question, okay? It can't be seen. Yes, I was expecting such an answer, not formed on the screen. Okay, yeah, absolutely correct, right? Cannot be caught on the screen, right? See, just try to understand over here the very important point. What exactly is the major difference? How you identify, how you distinguish whether a image is virtual or real? Okay, no, this is not the correct explanation. Okay, just try to understand this part. Okay, see, a real image is formed when the rays are actually meeting. Okay, real image is formed when the rays are actually meeting. Okay, but a virtual image is formed when the rays are actually not meeting. Instead, they appear to meet. Okay, the rays are actually not meeting, but instead they appear to meet. Okay, just focus on what I am saying. The basics, very basic difference between a real image and a virtual image, right? Okay, so the real image is formed. Yes, I am trying to explain this part. Okay, Swat, just try to understand this part. The real image is formed when the reflected, see, there will be some rays that are emanating from the body, from your body, okay, from the body of this particular man, and moving towards this mirror, okay, and then they get reflected in some backwards direction. Okay, there will be a lot of infinite number of rays that are getting reflected back from the mirror, right? Okay, now the important point is that these reflected rays, when extended backwards, then they will meet at this particular point where we say that the image is getting formed. Okay, right? I hope you all know this part, right? That when we extend the reflected rays in the backwards direction, okay, then we actually obtain the image of the object, right? Right? It is formed behind them, right? I hope you understand this part, right? Now, what we are doing, how we are obtaining this particular image, it is obtained by extending the reflected rays in the backwards direction, right? Not by the actual meeting of the rays, not by actual meeting of the reflected rays. Do you understand the difference between the two cases? That I just told you, okay? What about the rest of you guys? The virtual and the real, right? The difference, right? In this case, what is happening is that the reflected rays are not actually meeting, right? We have to extend them in the backwards direction, okay? And wherever they will meet, at that particular position, an image will be formed, okay? Right? But in the real images, what happens is that we do not have to extend the rays in the backwards direction, okay? Instead, the reflected rays actually meet, okay? They will actually meet at a particular position, at a particular point, and at that particular point, the image will be formed. That will be a real image, okay? And therefore, we say that if you place the screen at that location where the reflected rays are actually meeting, okay, then you will obtain the image of that particular object in that screen, okay? The thing that you are saying about the screen, okay, I hope you are now able to understand that why we say that, because we are not able to obtain the image on the screen, okay? Because we are not able to obtain the image on the screen, therefore it will be a virtual image, okay? It is because the rays are actually not meeting, okay? The exact reason, I hope you are now able to understand of this part, okay? Why we say that it will be a virtual image? It is not because its image cannot be obtained on the screen, right? But that is the partially correct answer, okay? It is a virtual image because the reflected rays are not actually meeting, okay? That is the correct explanation. And then you can add up. Then you can add up in the answer that since the reflected rays are not meeting, therefore the image cannot be obtained on the screen, and hence we call it as a virtual image, right? Okay, I hope you have understood this particular explanation for the question, okay? Right. So the other property for this image of using the plane mirror is that it is a virtual image, right? I hope all of you have understood by now that image will be a virtual image. Yes, it will be an erect image, okay? and a laterally inverted image also. Okay, lateral inversion will also be present. Okay, yes, the rays are actually not diverging. Okay, the rays are actually not diverging. Diverging means like a rays emanating from the torch from the torch. Okay, the rays in the light rays in the torch that is diverging. Okay, right. But when you are using a plane mirror, okay, in the plane mirror the rays are not diverging, right?